Hey guys, thanks for watching how to graph linear equations with a table of values. I do lose it a little bit in here and start singing, so I apologize in advance for that. But watch, pause as needed, take notes, and recheck your notes because your test is coming up. Have a good day. Today we will begin graphing linear equations with a table of values. Let's review some important terms. Please write in your notes that the x represents the independent variable and is our input values. This means we can choose x values to plug into the equation or input into the equation and solve them for y. So let's add that y is the dependent variable, which is also known as the output. One more important definition we need to include is the definition of a line. A line is composed of an infinite number of ordered pair values. So when we're choosing some numbers to plug into our input, some x values, and we're going to get an output, our y values, those are just some of the infinite number of points that are going to be on a line. So let's look at some examples of a table. Now, I'm not talking about the table you eat your Sunday dinner on. I'm talking about tables in math. The first example is a vertical table. Notice that x is on the left and the y is on the right. Most of the time in your table, your x's will follow a pattern, usually increasing, and then if it's a linear equation, your y will also follow a pattern. The second type of table could be a horizontal table, where x is on the top and y is across the bottom. I would like to point out that x is either on the left side of a table or on the top of the table. And remember, x is your input values, also known as the independent variable, and y is your dependent values, also known as your output. So again, x across the top is input, y across the bottom of the table is output. The tables that we're going to use in our class look like this. Example 3. And I know it seems like a lot of work and it seems pretty overwhelming, but it has all of the information we need to graph a line organized in the table. On the left side you have your x, which is your input. Then the equation comes next, where you're going to plug in your input values. Y, your output values, will be the next column. And then the last column is just the ordered pairs, written as x, y. For our class example, I want you to watch me. Well, I'm not going to whip and nay, but I am going to graph y equals 1/2 x minus 3. The first thing I'm going to do is I'm going to create a table. On the left, I'm going to have my x. Then I'll write my function, or my linear equation. The third column will be my y, which is my output. And the final column will be the answers written as an ordered pair. It doesn't matter what values you choose to plug in for x. Everyone in the class could plug in their own numbers. However, I like to stay centered close to the origin, unless it's a real-world example with some bigger numbers. And I like to plug in positives and negatives and also a 0 for the y-intercept. So for every problem we work today, I'm going to plug in the -2, -1, 0, 1, 2. So I will replace x with -2 and evaluate. I'll replace x with -1 and evaluate. And I'll do the same with 0, 1, and 2. Now I want you to notice something. The y is in the equation, the 1/2 is still in the equation, and the -3 is still at the end. The only thing that changed was x, your input. So now it's time to find our output values. So for my column for y, I'm going to plug in 1/2 times -2 minus 3 in my calculator, or I can use the calculator in between my ears. For some of y'all, that's your brain if you didn't get it. It'll be -1 minus 3, which is -4. I'm going to do the same for each term. -3.5. Evaluate with a 0. That's -3. Evaluate with a 1. That's -2.5. And finally, evaluate with a 2, which will be 1 minus 3, and that's -2. Now, if you'll look down the column for my x's, from -2 to -1 to 0, 1, 2, all of the x's are increasing by 1. That's a pattern. If you look at y, all of the y's are increasing by 0.5 or 1/2. The same pattern. So if your input values follow a pattern for a linear equation, your output pattern, your output would also follow a pattern, and then you would know if you got a problem wrong or not, okay, just by checking. We're going to take these, we're going to write these as ordered pairs. That'll be our last column. Remember, an ordered pair is made of an x and a y. So put your input first, you put your output last, you put your input first, and you shake it all about. Maybe I should apologize if someone is actually listening to me on this video. We have a -2, -4, a -1, -3.5, 0, -3, 1, -2.5, and 2, -2. So guess what? We have 5 points. 5 points that we can plot on a coordinate plane in order to graph. Y'all, it's like magic. Look at my coordinate plane just appeared on the screen. Let me move this out of the way and I'll pull my coordinate plane back over to the side, and I'm going to plot my 5 points. If I did this correctly, these 5 points will form a line. First number, -2, to the left 2, down, 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 down to -4, put a dot. Next point is -1, and then down -3 and a half, so right in between. 0, no left or right movement, down to -3. 1, -2.5, and 2, -2. As best you can, draw a line through your points. Now this line does extend to -infinity on the left and +infinity on the right for the x's and the y's. So we could find more points, but I think 5 is a very good number. So here's the worksheet we have in class. We're going to start with number 1. You have a table and you have a coordinate plane. We're going to plug in the same old numbers. -2, -1, 0, 1, and 2. And we're going to evaluate. I know you see in front of x there's a fraction. I'm sure you are so frightened, but guess what? It's okay, because we're going to use our calculators. So please fill in under the x, -2, -1, 0, 1, and 2. Just a reminder, these are our input values. So let's replace every x with these values. 5 numbers means 5 different times. We're going to need to simplify that numerical expression on the right for our output. So you'll notice the y, the 1/3, the +2 are all constant. but we did change each time x, and we plugged a number in. So we have a -2 that we're going to evaluate, and I'm going to be pretty lazy, and I'm going to use my calculator to evaluate. So I'll be on my home screen, and I'm going to type in 1/3, which is 1 divided by 3, times -2, and I'm using parentheses, plus 2, enter. My output is a decimal. Well, it's 1.3 repeating, so I'm going to write 1.3. I'm going to put a bar on top. You can go ahead and round that to just 1.3. We're going to do the same thing with -1. And I'm going to cheat a little bit here. I'm going to press second enter, which brings the last function I just typed in up. And I'm going to scoochie on over and change that 2 to a 1. So now it says -1. Enter. And I have 1.6 repeating. You can round that to 1.7 if you'd like. Continuing the steps, second enter recalls the same function. I'm going to use my left arrow key to go over and change -1 to a 0. Press enter. And this solution is 2. Second enter. Plugging in the 1, 1/3 times 1 plus 2, 2 1/3, or 2.3, and the 3 repeating, so I'll place the bar over the 3. And finally, plugging in a 2. 1/3 times 2 plus 2 is 2 2/3, which is 2.6, with the 6 repeating, or you can round that to 2.7 on your paper. So let's see if we can write some ordered pairs now. We're going to put our input first and our output second. So my ordered pairs would be -2, 1.3, -1, 1.6, 0, 2, 1, 2.3, and 2, 2.6. I'm going to take these ordered pairs, and I'm going to graph these on the coordinate plane to the right, and you should be doing the same in your notes. I'm graphing decimals, but my coordinate plane is scaled by integer values, an integer value of 1, so I'm going to have to estimate as best I can. -2, up, 1, and just a little over the line. -1 and up, a little more than halfway between 1 and 2. 0, 2, 1, 2.3, so just a little above the line, and finally 2, 2.6, so a little more than halfway. As best I can, I'm going to draw a line to connect my points. Hey, I'm doing the best I can here. So what if instead of plugging in my same old numbers, I chose to plug in -6, -3, 3, and 6. Check out the original equation. There is a 1/3 in front of x. So if I choose values to plug in for x that are divisible by 3, voila, I do not have any fractions for my output. So we could work this same problem. We could not pick the -2, the -1s. We could pick numbers that are divisible by 3. But since we're using our calculator, I chose to plug in the other values. But when we plug in the -6, we get 0 for the y. And if I were to extend my red line, -6, 0 would be on my line. If I plug in the -3 and simplify, my output is 1. So notice when you graph -3, 1, you're on the line. You do the same thing with 3. Plug in a 3. 1/3 times 3 is 1, plus 2 is 3. and 1/3 times 6 is 2, and 2 plus 2 is 4. Both of these values are also found on the line, the 0.33 and the 0.64, and I'd have to extend that line out. So you can choose any number to plug in for x and solve for y. Sometimes with a fraction, it's easier to choose numbers that are divisible by that denominator. Otherwise, estimate as best you can on your graph. Our next equation would be a little more difficult because this equation says 2x minus y equals 2, and it is not y equals. What equation form is this? It's in standard form, ax plus by equals c. So you have a choice. You can plug in your input values and solve every time for y, or at the very beginning, you could take this equation and solve it for y. You have a choice. What would you like to do, class? Okay, everybody wants to solve the equation for y. Correction, I think the class wants me to solve the equation for y. So over here on the left side, let me doodle some notes. To solve for y, the first thing I need to do is move my x term from the left side to the right side. 2x is positive, so when I move that term over to the right side, I'm going to do the opposite of adding 2x, which is subtracting 2x. And my new equation will be negative y equals 2 minus 2x. This is still not y equals. This is negative y equals. So I need to get rid of the negative in front of the y. So what's the opposite of multiplying by negative 1? It would be dividing by negative 1. So take every term and divide it by negative 1. Here we go. Y equals negative 2. Oh, and check this out. A negative and a negative. So that's going to end up being a plus. And 2 divided by 2 is 1. 2 divided by 1 is 2. Negative 2 plus 2x. So what I'm going to do is I'm going to go back to where I have my equation written in my table. I'm going to scratch that little sucker out, and I'm going to change that to say y equals negative 2 plus 2x. I can type this straight in to my calculator to find my missing values. And with a little editing magic, there are my negative 2, negative 1, 0, 1, 2 plugged in down the left side. And I'm going to use some magic again and fill in for x, change my input each time to be the numbers I have in the x column. So you'll notice that I've plugged in for x, negative 2, negative 1, 0, 1, and 2, and now I'm going to evaluate. Again, you can use the calculator between your ears or the calculator provided in class. If you're having trouble typing these into your calculator, please see me, but otherwise, here we go. Here's my answers. I have my output filled in purple and my coordinates, my ordered pairs, in the far right column. So now what I'm going to do is I'm going to transfer those onto my graph. So look at the pattern. From negative 6 to negative 4 to negative 2, 0, 2, I'm increasing by 2 each time. Here's a little extra piece of information. This is totally free. That's called the slope of the line. X is increasing by 1, and on top, Y is increasing by 2. So my dots are going to be negative 2, negative 6, negative 1, negative 4, 0, negative 2. And by the way, 0, negative 2 is called the y-intercept. Good stuff. The next point is 1, 0. Oh my goodness, that one also has a special name. That's the x-intercept. And then the final point is 2, 2. Beautiful line. Sketch the graph, please. The next two problems are so easy that we tend to make them difficult. Check out this equation. X equals 3. There's no work to be done. X equals 3. It always equals 3, forever, to infinity and beyond if you're Buzz Lightyear. So what does that mean? Well, first of all, that means we don't need to show any work right here. There is nothing to plug in because in front of your y, you had a 0 as a coefficient, so that little term cancels out every time. So then any time you plug in for y and solve, it's going to cancel out. You're going to have x. So I could actually move my inputs over there where the y would is that we would normally put in for x. So negative 2, negative 1, 0, 1, and 2. No matter what you do, x is always going to equal 3. So if you write those as ordered pairs, you'd have 3, negative 2, 3, negative 1, 3, 0. Remember, that's the x-intercept. 3, 1. And 3, 3. And what kind of line does this make? Of course, a vertical line. And the way I used to remember this when I was in school, just like a day ago, seeing the letter X made me think of the X Games, and the whole point of the X Games is to see how vertical you could get, how far in the air you could get. So I always remembered that X equals was a vertical line because of the X Games. In our next example, we have y equals negative 3. So guess what? Y equals negative 3 no matter what x is in this equation, always and forever. So what does that mean? If you don't have two variables to plug in for, there is no work to be done in the middle. There was a 0x in this equation, and anytime you have 0 next to a variable when you plug in, you're going to get a 0. So if we were to plug in our input values again for x, negative 2, negative 1, 0, 1, and 2, there's no work to be done because the output is always going to be negative 3. So this is not a vertical line because it's not x equals, it's y equals. It's going to go the other way. It's going to be a horizontal line. Negative 2, negative 3. Negative 1, negative 3. 0, negative 3, which, by the way, is the y-intercept. 1, negative 3, and 2, negative 3. There is only a y in this equation, so I can only touch the y-axis when I graph it. And what's the only way to do that is to have a horizontal line. If this line were to tilt any or slope up or down, it's going to touch the x-axis. Are you bored yet? Well, I'm going to go through the next two problems very quickly, and I'm going to skip a lot of things. So if you have any questions, you need to see me. Thanks. Example number 5 is another equation that's written in standard form. So I think it would be worthy of our time to go ahead and solve this for y. We're going to have some fractions, but you know what? It's okay. We can make it together. So we're going to take this equation. We're going to solve it for y. The first thing I need to do is move the x term to the right. And anytime you move a term, you're going to add or subtract. So the opposite of adding 3x on the left is subtracting it on the right. 2y equals 1 minus 3x. This is not solved for y because there's still a 2 in front of the y. So the opposite of multiplying by 2 is dividing by 2. So take every term and divide it by 2. These would be decimals that terminate. So if you want to write 0.5 and 1.5, you can. I'm just going to leave them as fractions. 1/2 minus 3/2 x. So I've done a couple of things. I've marked out my original equation and written it in slope-intercept form. And I filled in my input with negative 2, negative 1, 0, 1, and 2. The next thing I'm going to do is plug in for x. Notice that the y stays, the equals, the 1/2, the minus, the 3/2, and then you're going to fill in for x. In order of operations, we're going to multiply before we do that subtraction. But if you're using your calculator will do that for you. And it's like I snap my fingers and the answers are there. So I do have a pattern for y, had a pattern for x. Again, it should be linear. I'm going to come and I'm going to graph my points. Negative 2, 3.5. Negative 1, 2. 0.5, 1, negative 1, and 2, negative 2.5. They form a beautiful line. I'm going to draw the line through those 2 points. Put my little arrows on the end. I like to fill up my entire coordinate space. You don't have to do that. I'm just a super nerd. And this last equation should be very easy because it's all for y. There are no fractions, no decimals. Life is good. So I've plugged in my input for x. And I'm going to go through and fill in my little table with my x's changed. And I can use my calculator between my ears, the calculator on my desk to evaluate. Now look at how fast I'm going to write, maybe with a little editing magic. I'm going to fill in my y's and write my ordered pairs. And the final step is to take those ordered pairs and plot them on my coordinate plane. I'm going to fill in my whole space. We obviously didn't find that many points. Look at how good that looks. Happy studying for table of values.